Hello everyone here. Our panel is about the mega fires, climate change, and post-fire restoration, and how post-fire restoration is related with climate change, how will be affected. And we have three presentations here. One of them is me, and other is Hugh Safford from University of California, Davis, and for United States Forest Service. And the other is Nesibe Köse from Istanbul University Cerrahpaşa Forestry Faculty. And me is Çağatay Tavşanoğlu from Hacettepe University, Turkey, Department of Biology, Ecology section. I hope it will be useful discussion about fires and fire regime changes, how they be affected, and how mega fires occur all over the world. And we can start with Hugh, the first presentation. You can come.
So this is working. Oh, fantastic. Thanks, Çağatay. I'm going to be talking about climate change and post-fire restoration in Mediterranean-type ecosystems in California. I'd intended to talk a little bit about some of the, thank you so much, about some of the efforts that are going on in Spain as well. I probably won't have quite so much time to do that given our short time. I'll refer to them. Next, oh, so I go with this one, yeah? Like there? Okay. So I'm going to start our session with 4 or 5 slides about general Mediterranean climate issues that apply to all 3 of our talks. Most of you will know this, but there are 5 Mediterranean climate zones in the world: Mediterranean Basin, most of California, northwestern Baja California in Mexico, central Chile, the western Cape of South Africa, and western and southwestern Australia. They're unique primarily because of their climate, which is characterized by cool, wet winters and hot, dry summers. The Mediterranean climate regions are small. This is only about 2% of the world's surface. They are highly populated. About 600 million people live in the 5 Mediterranean climate zones on Earth, which is about 7% of the world's population. And there are a number of countries that have very high growth rates as well, over 1%, depending on where you are. They're extremely biodiverse. For only 2% of the world's land area, they actually support 20% of all of the described plant species on the planet. And they're also highly threatened, particularly in the old world. There's a very long history of human occupation in these places, obviously. In all of them, there are relatively high population densities. And as a result, we have high levels of ecosystem fragmentation and ecosystem degradation as well. So the Mediterranean climate regions at the same time are under very extreme threat from climate warming. I've just provided 3 examples here for you. One is Southwestern Australia, which is one of the places on the planet that's seen the most profound loss in precipitation in the last 50 to 60 years. It's causing major ecosystem issues in Southwestern Australia. The Mediterranean Basin itself is actually one of the fastest warming parts of the planet, especially outside of the boreal latitudes. And in California, rapid warming is leading to a major change from heavy snows in the winter at high elevations to much more rainfall, which is creating major issues for water delivery, well, for ecosystem issues, obviously, but also in water delivery in late summer to the most important agricultural state in the United States. So we're focused on forest and woodlands in this presentation. So I'll just note that depending on the system you're in, it's either has a lot of forest or very little. For example, the South African system has very little forested, a very small forested landscape. So they're only about 0.5% of the world's surface, but they provide very important ecosystem services for the 7% of humans on Earth that live in the Mediterranean climate regions. We're talking about water quality and quantity, soil protection, provisional services such as foodstuffs, timber, fuel wood, some carbon stocking. It's not nearly comparable to the Amazon basin, but some of these forest types hold quite a bit of carbon. And obviously there are very important recreational, other socio-cultural services and biodiversity as well. So fire is the most important ecological disturbance in the Mediterranean climate regions. The unique climate that these systems have mean that in the winter, there's generally enough precipitation to grow quite a bit of fuel. But then in the summer, we don't have any rainfall for 4, 5, 6, or even 7 months, depending on which zone you're in. And so it's a perfect setup to burn a lot of fuel in most summers if there are ignitions. As a result of this close ecological connection to fire, many species and many ecosystems are dependent on fire occurrence. There are a lot of species whose regeneration is cued or abetted in one way or another by fire, and biomass and nutrient cycles are closely influenced by fire. For example, in drier parts of California, Turkey, places like this, fire actually is the principal decomposition factor for biomass on the landscape. One really, really important issue to take into account is that humans have massively altered the natural fire regimes across most of the Mediterranean climate regions, and I'm just going to provide you an example of the situation in California, but it's germane to all of the Mediterranean climate regions. So there are places in California where we have too much fire, and these are characterized principally by shrublands. In the case of Southern California, a system that we call chaparral, or also coastal sage scrub, and to an extent in sagebrush or artemisia systems in the Great Basin part of California. And in these systems, there is very little or no lightning ignition, so all fire is caused by humans. And currently, because of the heavy population densities in Southern and Western California, there's a lot of fire, and there's too much fire to maintain woody vegetation on a lot of the landscape anymore. This is leading to invasion by exotic species, loss of woody cover, increases in erosion, increases in stream sedimentation, and major impacts to biodiversity as well. On a lot of the landscape, though, as well, there's too little fire. And in fact, the Western U.S. fire problem is characterized principally by the effects of what we call fire suppression. So for about 100 years, federal and state fire management agencies have been putting out nearly all fires on Western landscapes in systems that used to burn very frequently due to both lightning ignitions and ignitions by indigenous or Native Americans. And so for much of the higher elevations in California, we've had fire exclusion, removal of indigenous burning, putting out of all fires for 100 years. And as you can see in the pictures there, we've gone from a system dominated by pines and very open forest structure to systems dominated by fir and other shade-tolerant species, essentially a jungle of fuels that when it burns now, the effects are generally deleterious and damaging. So here are a couple of trends for California. Both wildfire area and severity are increasing rapidly in the state. I've only shown from 1980 to 2021 because from 1930 to about 1980, there's not much change. There was an average of about 1,000 square kilometers burned in California in an average year with some variance around that, and that was due to the effectiveness of fire suppression policies. However, after 50 years of accumulating fuel, combined with warming and drying climates, we've now lost the ability to control these fires any longer. And you can see beginning in about the early 2000s, there's a really strong rise. The dotted line is the 5-year running mean, by the way. The red dots represent years in which more than 405,000 hectares burned in 1 year in California. 1 million acres was the value we'd use in English. And you can see that all of these years have occurred since '99. There are none of them earlier, except for way back. And 4 of the last 5 years have burned this large area. So the point I want to make with this wildfire graph, however, is that ecologically speaking, the area burning is not a problem. It's a problem for human health. It's a problem for fire risk to homes that have been built in highly risky landscapes. But that line at the top, at 18,000 square kilometers, is the best historical estimate we have for the probable annual area that burned in California before the arrival of Europeans. So you can see that most years don't come anywhere near that. So as an ecologist, I'm not concerned with this. What I'm concerned with is the way that fires are burning. And we measure that through what we call severity. And what severity is a measure of the loss of biomass on the landscape. So our definition of high severity for this graphic is parts of the landscape in which more than 90% of the above ground biomass has been killed by fire. And you can see that there's a very strong rise in this measure, again beginning in the late 1990s and early 2000s in particular. Okay. All right, so anyway, so now to the general purpose of my presentation. What do we do with these huge and growing areas of burned and degraded land in a place like California? There are a lot of barriers to post-fire restoration. They range from funding and institutional capacity. For example, the U.S. Forest Service, which thinks of itself as a large agency, actually manages 80 million hectares in the U.S. with a staff that's only half as big as the staff of a single international airport, like Chicago O'Hare or Atlanta Hartsfield. Kind of scary when you think about it. There are major jurisdictional differences to deal with: federal lands, state lands, private lands, smallholder lands, corporate lands, for example, varying stakeholder viewpoints and interests, industry, environmental groups, agencies, the public, for example. Conditions are changing under our feet. Climate is warming very, very quickly. Populations are increasing very quickly. New invasive species show up all of the time. There's a relatively inefficient and definitely insufficient interaction between science and management. That will generally be the case. And finally, and I think this is maybe the most important, is we're lacking a strong prioritization framework. In other words, when you have limited funding, limited capacity, and limited time to make a real difference, you have to make sure that every dollar, or every Turkish lira in your case, is being spent wisely and that there are effects that you can actually measure on the ground. So what I'm going to do for the rest of the presentation is present you with a series of initiatives, and projects and tools that I and my staff in the Forest Service have developed over the last 15 years to help in prioritizing where we carry out restoration and what kind of restoration we carry out in burned landscapes. So I'm going to start with the post-fire restoration framework for the California National Forests, which we published earlier this year. And I'm not going to spend much time in most of these. I'm just going to introduce them, and then will these be available to people to find somewhere? Maybe there's a link? Or you can take a photo or something like that too. Anyway, I've put down the links to all these publications and also the links to the tools so you can go find them as well. So this document, it's a pretty big document, but the concept is pretty simple. It's based on 6 restoration principles. Restore key ecological processes, make sure that we're considering the larger landscape surrounding the fire as we consider the burned area. We're interested in promoting native biodiversity. We want to sustain and promote different kinds of ecosystem services on the landscape. We'd like to establish a useful prioritization approach. And finally, we want to incorporate adaptation to agents of change, climate change, again, invasive species, growing populations, et cetera. So I think I skipped the next one. Yeah. So anyway, again, I want to highlight that I think that prioritization really is a major key here. And in fact, if you look at just the history of COP, and the history of payments, for example, for ecosystem services or for carbon offsets, carbon stocking, the big issue is, are we wasting money? And in a lot of cases, money was wasted at huge scales in a lot of places, and that is due to a lack of efficient prioritization and also validation on the ground of the effectiveness. And this is, the adaptive management cycle is really important. So we've worked with partners to develop a bunch of tools. I'm going to talk about 3 of them. Post-fire restoration planning tool for chaparral habitats, Postscript tool for conifer forests, and a tool that's built by a partner of ours called Lantender for all ecosystems. Okay, so this prep tool, and there's the publication earlier this year that we put out on this thing, and that's down at the bottom link, and also you can see a webinar about using this tool on the landscape at the top link there. Had a bunch of partners involved in it. To simplify this tool, essentially there are a whole series of spatial data inputs that go into this. We start with species information. Again, we're talking about a shrubland landscape. The differences between species that only reproduce by seed after fire versus those that can resprout after fire is hugely important in terms of ecosystem services, carbon, and all sorts of things. So that's the place that we start. And actually, it's the most complicated part of it, understanding where they are in the landscape. Then we incorporate information on fire history, fire frequency, severity of fires, how recent were fires, drought conditions both before the fire event and after the fire event. They have major impacts on regrowth, obviously, and survival of seedlings. And finally, invasive grass cover, which competes very strongly with the seedlings of these species, but also provides a fuel bed for future fires. Those together provide us what we call regeneration capacity, and that's on the left side of the little of the decision matrix off to the right. And then at the end of that, we can add some information on risk of soil erosion. And when you cross these two, we can get ecosystem degradation risk on the landscape. So there are a number of different outputs, but here are two examples. So this is from the 2002 copper fire in Southern California. This fire was about 20,000 hectares. And you can see that we have areas mapped that have high regeneration capacity, all the way down to low. And then when we overlay that with the soil erosion risk, we have places within the fire that we can map as having very high or high degradation risk. Now, for me, I think the most interesting thing that we can then do is we can overlap those outputs with ecosystem service maps. And for this part of California, we've built maps that are available. Again, I'm sorry, I should have put the link on here because you can go find these as well. But in this case, on the map on the left, I've incorporated information on water runoff services, groundwater recharge, biodiversity mapping, and potential carbon stocking. We haven't weighted them, they're just stacked one on the other for the purposes of this presentation. But what it shows you then is where on the landscape we're able to get 1, 2, 3, or areas of 4 ecosystem services at high values. We can overlay those with the outputs from the tool, in this case regeneration capacity. And if there are so many areas of high degradation, this helps us to prioritize where we think we ought to do work, with the outcome in terms of its impacts on ecosystem services will be highest. Okay, so I just wanted to make a quick pitch. This is the Spanish post-fire restoration technical guide. This has been out for 5 years at this point. And this actually has been proposed as a standard for the Mediterranean countries. The Spanish government has adopted it. And I just wanted to note that this was a really, really important influence on our development of this tool and also on the post-fire restoration framework. Okay, so now this is the PostScript tool. Get a drink of water. That stands for Post-Fire Spatial Conifer Regeneration Prediction Tool. And I have to tell you that our original inspiration for this came from work I did with some colleagues at the University of Athens in Greece, Margarita Arianozzo and some other folks that you know who've been doing species regeneration mapping after fire. Again, we've published a couple papers on this tool. Those are linked at the bottom. And the top link is actually for a Shiny app for one of the more recent versions of this tool where you can actually import data layers and run it. So what this thing does is it takes fire severity mapping, and this is the Landsat-based relativized difference normalized burn ratio, or what we say RDNBR map. We produce these in the US for all fires above about 400 hectares. And that information goes into the tool. The 30-year climate averages go in this case precipitation, AET, climatic water deficit, and April snowpack. Some information on topography goes into the tool. And then finally, and this is the most important and most complex part, we do seed availability proxy modeling, which models seed availability for the different species on the landscape based on the fire severity and the pre-fire basal area. That's complex stuff. You have to go to the paper to find out more information on that. Otherwise, I would spend an hour explaining it. So what it spits out in the end is a map of regeneration potential for conifers within the fire perimeter. So this is the 2018 Walker fire. And what this map is telling us, all of the brown areas are areas where regeneration probability, that is, of encountering a regenerating conifer in a 70 square meter area up to 5 years after fire, is less than 40%. And we use that as a threshold, if you will, for areas that we're concerned and worried about maybe having to replant, okay? Whereas the areas in this fire that are in blue have a very high predicted probability of regeneration, and we don't need to worry about these. I won't go into the rest of the stuff. We've done cross-validation. The data that back this up are from thousands of plots across dozens of fires in California. And what these maps do is they very quickly provide foresters with a good idea of where they need to worry about regeneration of conifers. Where do we need to replant? Otherwise, it can take quite a lot of time walking the ground and thinking and adding data. This thing does it, and we can generate this thing in about an hour. And then we just deliver it to the unit. So an example of where this was used a couple of years ago on the Walker fire was using the old process managers identified potential planting units, looking at the size of the high severity patches, the vegetation, where they could afford to plant, these kinds of things. And then they overlaid that with the PostScript tool outcomes and used that to refine their planting units. I want to note that our latest version of PostScript also can incorporate different climate scenarios, and it also can incorporate different seed production scenarios, what we call masting. So we can generate confidence intervals for scenarios in which years after the fire are very wet, they're very dry, in which trees are producing lots of seeds, or in which they're producing very low amounts of seed. Okay, so this is the last tool that I'm going to talk about, and this is a tool called Lantender. This is developed by a firm called Vibrant Planet, who actually were involved in a couple of presentations here at COP earlier. This is a pretty complex tool, and I'm only going to go over it very, very superficially. It would be nice to be able to run through some of the spatial outputs, but we just don't have time. So what is really cool about this tool is it allows users and stakeholders in a project development scenario to balance the relative weighting of different management focus areas for all of the different areas in a fire. So for example, what we're using right now in the tool for California are what we call the 10 pillars of resilience. This is from a Nature Conservancy and Forest Service project that was finished a couple of years ago. And essentially, the tool then has inputs for every one of these different pillars: water security, social and cultural well-being, fire dynamics, carbon sequestration, biodiversity conservation. And so people working together from industry, from environmental groups, from agencies, from, you name it, they can all sit, local individuals, people economically interested in the project area, they can all play with scenario development, focusing more on one thing or another thing, and that these can be modified based on where you are in the landscape. What it is it's an optimization tool, basically. It includes fire modeling in it. We have some climate change algorithms, and it actually has a forest growth model behind the system as well. And so we've got 3 different scenarios here. The one on the left was just, we have all of those pillars weighted equally. The one in the center was focused mostly on forest resilience, biodiversity, and fire dynamics. And the one on the right had the same focus, but it had a different number of projects that were set up for the scenario. But you can see that it can actually model these things out over time. Right here, it's set to model outputs over 30 years. And you can see that it gives you the relative balance in terms of the relative return on investment. And in this case, we're talking about, management investment in each of these things. I mean, this is actually, I can't do justice to this tool. This is really a groundbreaking tool in a lot of ways. And then what we're doing currently is we are retooling the tool, for post-fire situations. Right now we're using it mostly in green forest or green landscape management, but what we want to be able to use it is in providing input into post-fire management. And so this is the Caldor fire from this year in the Lake Tahoe area. And you can see that we've got forest resilience.
COP delegates, we kindly remind you to wear your face mask over your mouth and nose at all times during your time at the conference, unless you're seated in a room with appropriate distance while eating or drinking or medically exempt. Thank you for your cooperation.
You arranged that so I would stop, huh? When I heard that, I figured they were going to tell us a plane or a train was leaving or something like that. Anyway, I'm finished. This is my last slide. But I just want to note that, so again, this is just we mocked this scenario up very, very quickly. But this tool provides us the ability then to provide managers and all stakeholders the ability to provide input to the project up front. Everyone can see how a project scenarios can be changed based on the inputs. And in this case, it has a few forest thinning and reforestation and prescribed fire projects. Anyway, I think that's my last slide. Great, thanks.
Thank you very much, Hugh, for this outstanding presentation on post-fire restoration. And the second speaker is Nesibe Köse from Istanbul University Forestry Faculty. Yeah.
I can't finish this.
Okay. At the end of the speech, then we will have a short discussion session. So if you have questions, any of us, you can ask at the end of this speech.
Okay, thank you, Çağatay. I would like to thank everybody who is listening me now, and I would like to special thank to Ministry of Environment, Urbanization and Climate Change for their kind invitation to us here to discuss fire issues and climate change. I'm going to talk about fire, climate and human interaction during the past 600 years based on the case study from Turkish Black Pine Forest. Okay, before starting the project description, I would like to introduce my team who we are working together, because background of the issue, there are a lot of people involved in. Some of them climate scientists, the others more training person or fire ecologists or students. But one of them is very important for me, Elim Ayşe Şahan. She had a lot of work on this project and research. At the left, you will see the Pinus Nigra, which is very ecologically and economically important species. This species can live very, very long time in the forest, and we can obtain a lot of information of its long-lived old-growth forest. Just before talking about fire, human interaction, I would like to give information about climate growth relationship about the species. Actually, I spent most of my scientific life working on climate change, climate growth relationship of the forest species. I just would like to summarize that Pinus Nigra needs major precipitation much during the summer and spring, and didn't like so much high temperatures for its growing process. And one more slide for how climate change affects on black pine growth. It is a very long story behind this picture, but I can tell that you will see at the top of the figure, you will see the growth trend of the Pinus Nigra, and the lower part, you can see that the growth pattern and also temperature pattern and precipitation have changed May, June, July, and during August. We easily can say that after 1975, drought, trade, growth of the Pinus Nigra forest and this species threatened by the drought, and also there are a lot of tree mortality nowadays observed in the Pinus Nigra forest. Now we will talk about another trait, or the good thing, I don't know, for this forest, about fires. Okay, just before the beginning of the project, we had a question, research question in our mind, and the question was, how does climate change affect fire regime of black pine forest in Turkey? And we know that we need long-term recourse to answer this question. But everybody knows that Forest Service has some recourse, but they didn't go back so much, maybe 70 years before, but not much. But so many times you cannot reach of this recourse in the Forest Service. So we need another tool to understand long-term recourse of fires. This species, Pinus Nigra, adapted to surface fires rather than crown fires. What does that mean? Fire burn the understory of the forest and hurt the bark and cambium creates a scar on tree rings. And in this way, we can find a way to go back in time to see the fire records. just listening to Pinus Nigra trees. And now, how can I show you? I'm not sure. Okay, it works. What we are looking, we are searching very, very old Pinus Nigra trees in the sites like that. We call this shape as cat face. If we see this kind of forest, very old forest, we are taking samples from these trees or the stems in the forest. How tree rings can be used as fire recourse? I will just give a very short information about tree rings. Maybe you know a little bit. Each tree produces a ring, light part and dark part here you see, in a year. And when you are counting these rings, you can reach the date of the fire, which come you make a scar just like here. We just count and measure all the rings to go back in time and date these scars during the project. Okay, where we worked, this is the nature distribution map of Pinus Nigra. See here the red color. And we sampled a lot of Pinus Nigra, old Pinus Nigra forests from north, from middle, and from south to see how climate change affects Pinus Nigra forest fires. How we collected samples from the stems, like that, very, very old trees, you can find that trees in the area. And also, sometimes we use living trees. We just take a piece from the tree, but tree live there. And we obtained all these samples, and we work more than 200 samples on this project. And also, we had another data, documentary data, obtained from Forest Service in that areas. And also, at the laboratory, we dated all the fire scars or scarlets, like that, on the old samples. And finally, we published the first publication, very recent publication here, just from the Kütahya part of our project. And I'm going to talk about the results. What we are doing, we all the time dating these scars. I just would like to talk about the figure to understand better, but it doesn't work where I'm going to walk here. Look at here, all the sites you can see easily from here, and these all the trees. For example, this is one tree, and all these vertical lines are the signs from the fire scars. These are the fire sites, and we obtain generally sites or regional fire chronologies from the sites. Also, I would like to just mention that you can see there are a lot of fires occurred in that part during the time, and when we come here, we can't see so much major fires. Just keep in your mind. And we did it for all sites like that, and we go back time almost 600 years over Turkey. You can see here in Sparta also we go back so much. And another fire chart. And what we find at the end, we found that mean fire frequency all over the Turkey is between 600 and 800 years, which means black pine forest burns this year's periods. And also we can find another information about tree rings, which is fire seasonality. How we can understand that? We are just looking for early wood and late wood formation, and where is the fire scars, and easily can say that most fires occurred in the late wood formation, which means from August to September, October, in Turkish black-pine forest, but at the same time, it didn't change during the 600 years, which is very important. We can say that under the 600 years climate, the fire seasonality didn't change so much. And also the documentary data corrected all the information for the last years. And the other question was that, what is the causes of these fires? And in the area field work, we saw some lightning scars, some scars caused by lightning. And then also, when we checked the documentary data, most of the fires also caused by lightning, if it is recorded or its reason is known. Okay, then what we did, we checked fire-climate relationship to try to understand what happened. But our time depth was too long, and meteorological data, recorded data, is not enough to test this relationship. So we used Old World Drought Atlas, which created by Ed Cook and a huge team, which has included me also. This can go back centuries, thousands of years. So we just take some grids from this drought data and check what is the relation between fire events and climate during the 600 years. And it was really interesting. Some of the Pinus Nigra forests very well related to the drought. If there is a big drought in the area in that year, fire year, it is most likely possible to be a big fire there. This two upper and middle part, you can see this very statistically significant relations, but at the bottom, we couldn't find any statistically significant relation. This is the area, this place, in the Mediterranean region, but for the other parts like that, like here, we find very good relationship with drought. We cannot explain what is the reason why we couldn't find in that area very good relationship or significant relationship between forest fires and climate. We are just searching the reason now. But we can say that Turkish black pine forests tend to burn in drought years, very, very drought years, which means drought cause another threat for this black pine forest. It is very important results of the project. And also, we would like to see what happens in some years. Most of the fire scars we observed in all areas maybe. Most of them the years in 1954 or like that, most of them was very, very dry year in, when you look at the Spatial Drought Atlas. This is another clue. Can say drought is very important, this big fires. And also what we did, we compare our results, obtained the results from Spain and Greece. Why we choose these countries? Because these countries has the data, the same similar data, but the biggest data now from Turkey, they have just the data very, very small, from very, very small areas, not very especially large areas. So what we found that common major fire years was 6 years simultaneously occurred with Greece, and only 4 years with Spain. Why we found less agreements with Spain? Because we are close to Greece, and our climate also closer than the Spain, as you know. So, at the beginning of the project, our hypothesis was that temperature is rising, getting rise, And we will find more and more and more frequent fires nowadays, but we didn't find that less major fires observed in the most of the sites during the last century. It was surprising for us, and when we check the results, when we think about that, we found that fire suppression efforts of forest service was great. They just keep the fire in one tree, and they explained that they went there and they cut one tree and suppressed the fire there. This was very successful about this job. But the question is that this is a good thing or not. This is a paradox, which means if you have less major fires, you have more fuel accumulation, and you have a risk mega fires and crown fires. Why not? Because this species doesn't have ecology for crown fires, which means Pinus Nigra seeds doesn't survive after the fire. It means that genetic losses of this forest. On the other hand, climate change exists with extended fire season and more frequent fire weather conditions. It happens, the same thing happens there. And now I would like to explain one more side to you, on fire-human relationship. For the last, in the last, our last field work, we went to Antalya, and there was a great, very nice sampling site. When I go there, I saw a lot of lightning I have ever seen in the other areas. But when I go to the tree, I couldn't take samples because there are a lot of scars in the tree. I really surprised what happens here, and I recognized that there are Yurok culture, Yurok community living there. This community, as a transhuman community, they take their animals to upper sites and for grazing and browsing. I was unhappy. I took the samples, but I said, oh, what a, I didn't like this area. But I thought later, after this analysis is going on more, you can see that in that part, no major fires here, but the last part, a lot of major, more major fires, just different from the other sides, because the Yurok people are living there, and this has very, very long history. When I check their roots, they come from the lower part and they travel there, and they travel also to our sampling area, which makes less fuel accumulation, and maybe lightning was there here for initiation of the fire, but the fire cannot separate much. And at the end, what can I say? My take-home message from the project: climate change and fuel accumulation lead crown fire and major fire risk in black pine forest in Turkey. To protect and encourage Yurok culture means that protect our forests from fires, crown and major fires, and also maybe this is a question for foresters. Let black pine forest burn during weather condition to reduce fuel accumulation. This can be another solution to keep our black pine forest from major and crown fire risk. Thank you for your attention, and also I would like to say this project is supported by Tübitech. Thank you so much.
Thank you, Nesve, for this very nice presentation. That in the third presentation, that I will talk about post-fire restoration in Turkey, and especially the mega fires in Turkey that happened 3 months ago, and what will happen after that, and how climate change could affect these burnt areas and regeneration. So, I think we can use this. Okay. Okay. So, what is megafire? I just want to define this. It means that this is the out of the general trends. It means that there are some fires around at some size, but in some years, in some conditions, you have really large fires that unexpectedly high, and this means that you have a mega fire. In some regions of the world, you have sometimes millions of hectares burned area, like in Australia, sometimes California, Canada. But for example, for Turkey, it is 10,000 hectare burnt area is a mega fire, because this is out of the current fire regime, especially related to fire size. So this is the, this is not only Turkey's problem, it's a very global problem. This is the Australian fires of 2019 and 2020 winter, summer season. And California, you already talked about this. And there are also other regions of the world, like Siberia, and even the subarctic region. There are tundras are burning, and this is very problematic also for feedback mechanisms to climate change because of methane release. So, what about the Mediterranean Basin? This is what I am concentrate on. Mediterranean Basin mainly composed of two different vegetation types. There are forests and there are shrublands, and all are highly flammable vegetation. This is especially because they have some adaptations after fire to regenerate after fire, and they experience fires since millions of years. So we can say that all the Mediterranean vegetation is adapted to fire. And what we see in recent years is that fire regimes is currently changing in all the Mediterranean Basin area, including from the western part to eastern part. You can see the Portugal, Spain, Greece fires in recent years. And Turkey, this happened this year. This was the catastrophic fires, including burned cities and other places, and there are many economic damage happened. And this was at the same time, in 1 week, I think more than 200 fires occurred, and most of them we can consider that large fires, and many of them also were mega fires. So this was a very catastrophic event for Turkey. And these fires was unstoppable, because of the large amount of fuel accumulated in forests, and also the heat wave come from the creating a fire weather. And because of this, the struggle was very hard for Forest Service. And this is one of our study areas that showing the burn severity from the satellite data, that this is Marmaris area, and not everywhere burned very intensely, but you can see that there is diversity on this, and these many burnt areas are very touristic places, and people are living there. So the damage, socio-economic damage also was high in that area. So the question is that is climate change the reason of these fire regime changes? All these fire regimes, including Turkey, California, Australia, and other places. In fact, the answer is it depends, because in some areas of the world, yes, we can say that climate change drive fire regime change, and it increases sizes and intensity of burnt areas, like in Siberia, like in tundra ecosystems. Even we can say that Australian and in some sense, I think, North American systems, For example, but not in tropical rainforests. There are also a fire problem we are experiencing in tropical rainforests, but this is mainly because of the slash and burn practices and just for by human activity that's creating lands for agriculture and animal husbandry. So it depends, in fact. Not every time the climate change is responsible for. But in areas that we can say that climate change increase the number of fires or size of fires, a change of fire regimes is the only responsible. Maybe it is not. I will explain this with this area of a Mediterranean basin. I put this map, is very old map of Mediterranean area, because I want to talk about the old practices of human in this area, because this is a long history of human occupants in this area, and people use natural landscapes over thousands of years here. So what people did here, in fact, that we did make open areas around here because of our activities like agriculture, like wood cutting, like our browsers and grazers that we feed, like goats and sheep, and this make this Mediterranean landscape, in fact. What Mediterranean landscape is? The Mediterranean landscape is, you can see many things together. There are villages, there are farmlands, there are rangelands, there are forests, shrublands, and all these create a mosaic that they can find all over the Mediterranean area, including North Africa, Western Mediterranean area to Middle East areas. So what happened? What happened nowadays? The problem is that about the people, rural people migrate to especially the towns and cities in the last decades in this area, and making all this human landscape, human natural complex landscape empty, and all these fields, farmlands, all these grazing areas are started to be filled by shrubs and trees by natural regeneration or succession. And also forest services, governments also invest in reforestation or afforestation, like you can see the numbers areas that Spain and Turkey is leading all over the Mediterranean, that when there is an empty area, not empty, but there is no forested area, then we planted these areas. And both afforestation and natural regeneration result in fact, very continuous forested landscapes that if there is a fire, then you can stop it. Because there is no natural fuel breaks over there, and you can see the result. There are unstoppable fires, and we see that in fact in recent decades the fire size started to be dependent on the fire weather. In the past it was not like that in these areas. So we can say that if there's a heat wave, if there is very warm weather, then fires could be very large. But in the past it was not like that, because there are limitations of fuel breaks and open areas, and because people was in rural size of landscapes. But nowadays this is not like that. So all these things, there is a theory, we can say that we can Postas and Kiley's formulated theory. We also know this, but this is a good summarize. That the problem is that there are three thresholds deciding a fire, a large fire or small fire. So the one if is we need ignitions, and other is fuels, and other is draws. So what's climate change making this? In fact, What climate change making that these thresholds become lower and lower over years when the global warming affecting and also drought affecting. So this makes fire size higher and because of the availability of continuous fuel and also by extreme weather. So this is the theory. So I want to say that in Turkey's this year's mega fires make this theory to reality because we saw all the elements of this framework in these Turkish fires. More ignitions because of human activity, because all this touristic movements, also increased droughts make vegetation more flammable, and also continuous fuel due to rural depopulation happened in Turkey, and also afforestation. So now we can say about this, when there is a heat wave like in this summer months, then we may have very large and destructive fires in Turkey too, like in other European Mediterranean countries. So this may mean that, in fact, our fire regimes also change. Maybe another question is that is this just an exceptional year, or this is now our novel fire regime? So we will see during next years. So what to do after these fires, large fires? Before to discuss this, we need to know that all these fire adaptations, Hugh also told a bit, and they resprout, they have some cones that, like here in pines, store seeds and protect seeds from fire, and there are some seeds, there are some seed plants that accumulated seeds in soil seed bank, and during a fire they benefit from fire effect and they germinate. So there are many adaptations here. So what we see after these adaptations, that there is very huge potential of natural regeneration in these forests, and we can observe this in many areas, in fact. So there are some photos that from my studies, and this is a 3 years after fire in a Pinus Nigra forest, and you can see that many different plant species occupied all the vegetation just 3 years after fire, and you can see the burnt trunk and some seedlings of naturally regenerated Pinus Nigra. And also there are some seed plants, there are some resprouters, they all together, and all the vegetation regenerated. And this is a similar scheme. And this is the large fire, after the large fire. This is just 2 months ago, after just 20 days after one of these mega fires in Turkey. And just 20 days later after the fire, we saw that many spaces started to resprout there, because they are able to do, and they just don't wait for months, just 20 days later. And there are also some geophytes that also resprouting and even flowering you can follow, and there are other spaces like that. And also we observed that these serotinous cones protect their seeds from fire, and just 15 days after fire in another mega fire, you can see that they started to open, and they started to release their seeds to the soil. So there could be germinations after a rainy period comes. So this is how the system works after fire, in fact. So what we see after 1 year, or after the next rainy season, spring, I mean, you can see a very diverse plant community around these ecosystems, because many seed plants germinate, and you can see several species at the same time. And what is done actually after the fire? I can summarize that one method is just leave it as it is, the area, and allow them natural regeneration, like here. And other, if there is a purpose of growing trees because of some economical reasons, then yeah, then you can put some additional pine seeds to make this guarantee this area become a forest. And the other is the more destructive one, but sometimes used, that plowing all the area to decrease the competition with other species and planting pine seedlings there. As ecologists, we saw many things that this is most destructive, and this decrease biodiversity and also decrease the resilience of these shrublands and forests to both fire and also possibly climate change. So we need to very careful to use the last method during the restoration of Mediterranean forest. So I am finishing. There are several things happening, several ecosystem services present in burnt areas, and we should think about this. And nature recovery, we should use nature recovery potential of this Mediterranean forest. This is very important. So how will climate change affect? This is maybe there are many questions about this because very few studies happened on this, and we should think about how species interaction in plant or animal communities happen. How will post-fire mortality change because of droughts, or how post-fire germination and seedling growth will be affected because of climatic warming and decrease in rainfall, and how much seed production will be changed, and all of these how will affect long-term recovery dynamics of this Mediterranean ecosystem. So these are all unanswered almost questions. So we need to work on this. We need more experimental research, modeling, and also we need implementations and actions. But I want to point out that main focus of this post-fire restoration should be on biodiversity conservation and creating fire-resilient plant communities. Because during this climate change era, it is the only way to assist these forests to cope with climate change during their post-fire recovery. So this is what I am. This is the take-home message you can take. Thank you very much for this attendance. Thank you. And we are almost finished our time. I don't know if we have 5 more minutes or not, but if you have questions now, we can be here for a while. Maybe we can put our chairs here to ease this. Okay.
Sorry.
Yeah.
I just wanted to know, aside pine seedlings, what else would work for?
Size of seedlings, you mean? Sorry.
No, for the restoration.
Yeah.
There was focus on pine.
Yes.
So I just wanted to know, aside pine, the use of pine, what other would work in Turkey? Because
Yeah. This is mainly because of the burnt areas in the past was also pine forests. So this is the main goal of this restoration. But also this includes some economical purposes that these pines used in forestry activities in Turkey. So main focus of Forest Service is to grow in these areas, to grow pine ecosystems again.
So, but I'd like to respond to that because I think in Turkey this is going to be the same case as in the United States. And one of the things that we know is that a lot of the pine species that, well, for example, if I think mostly of a thing like a Pinus Nigra or Pinus ponderosa or Pinus jeffreyi, which grow in the US and are very similar ecologically speaking, they're adapted to a very specific kind of fire regime which is becoming very rare because of land management changes and climatic changes. And so what we have worried now is that because of how large and how severe these fires are becoming, it's becoming extremely difficult to conserve these species on the landscape. The only way to do that is through a lot of management input and starting to reintroduce fire where we've been removing fire, right? So The other thing, though, to think about is the most resilient parts of these landscapes tend not to be the pines usually, right? Pines usually, and many other conifer species, when you burn an ecosystem, you're almost always often you're going to kill the adult plant. The question is, does the adult plant have an adaptation to quickly respond? In the case of Pinus brudia or Pinus halepensis, or in our case, Pinus attenuata, yes, because they have seeds whose cones are actually opened by the fire, and therefore they benefit from the fire in terms of regenerating. But many pines don't have this. What is much more resilient are the broadleaf species, right? So oaks, a lot of the shrubs you were showing, pistachio, carob, whatever else. So one of the things that we're doing a lot more in California is thinking about trying to perhaps even aid forests to transition to forests that are more dominated by broadleaf species in the long term, because they're less apt for threshold responses of losing all of the biomass at once, because the oaks, they just resprout very, very quickly, and they recover pre-fire biomass relatively quickly. So anyway, I don't know if that answers your question, but climate change is forcing us to think about actually letting systems go in different directions than we would historically have pushed them usually.
Many thanks for your all presenters, for your inspiring, insightful, informative presentation. My first question is to Mr. Safford. In your country, California state, after the wildfire, is it common the outbreak, spreading, expanding of forest pests and diseases, especially deciduous stand? And second question is Ms. Nesibe, our professor. In the scope of to tackle with the forest fires, I wonder about the forest tending intensity volume, especially forest black pine. We know as a silvicultural techniques, can we change the classical forest tending intensity volume like thinning? We treat this kind of species in the young generation, this medium or low. Maybe can we increase our treatment intensity as a severe or high level? Thank you.
So I think your question was related to pest outbreaks after fire. Is that correct?
Pests and diseases.
Yeah. So to be honest, I think that we tend not to see huge outbreaks of pests after fire. It depends on the fire, and it depends on interactions with climate a lot, right? So most outbreak type pests and diseases in our forests, and I think it's probably the same in the Mediterranean, there are a couple things that drive them. One is stand density, right? High density stands, most diseases, for example, COVID, is a density dependent mortality factor, right? It's driven by how close everyone is. So very high density forests are very susceptible to outbreaks of beetles, for example, or passage of different kinds of disease. So that's one. The second one is that they're also very strongly driven by the health of the subjects. Again, in relation to COVID. Again, if you're sick already, good chance COVID is going to kill you. You know what I mean? So, so climate, drought, soil conditions, and density of the stand have major impacts on this. Then the other thing to think about is that our pine beetles are mostly, they're very similar to yours. They're, they're the Scolididae, same family, but it's a different genus, Dendroctonus, but they're the same thing. You have to remember that they attack live trees. These species don't attack dead trees. So when you have a system like a serotinous conifer, and it's burned very, very hot, the chances of having a beetle outbreak after an event like that seem relatively low. If you have low and moderate severity fire, then you leave patches of some, and maybe that can happen, but I think it has to be tied to beetle population cycles and also to drought. Our biggest beetle outbreak in California, which was the one that happened in 2013 to 2016, and it was huge, was not tied to fire at all. It had nothing to do with fire. It had to do with the lack of fire. because the lack of fire led to very high stand densities, actually. So because of the high stand densities and the drought, those interacted to create a big beetle epidemic. And then I'll just say, I'm going to give it to you, but I want to say in California, the reason that we decided to talk together is because we have a lot of the same problems. We have the same genera of trees. We have the same beetles. The climate is doing the same thing. And our toolbox for management, it's all the same. We have very few tools. You know, we have to reduce density. That's about it, you know, and there are lots of ways to do it. You can cut, you can masticate, you can chip, or you can burn. And the question comes down to biodiversity impacts, how much money do you have? Is there a timber market to sell the material that you cut? You know, all those kinds of things. So I think we're having the same questions, and in some places in California, we do think that there are mechanical ways to replace fire in some instances, but you don't get the biodiversity benefit if you do that. Anyway, I'll let you answer.
I would like to ask again, maybe in Turkish, because I think I missed some part of the question.
My question related to silvicultural techniques.
But
Türkçe olarak.
okay, I'm not a silviculturalist,
Yeah, okay,
so
okay,
because
okay.
I'm a botanist, because of
I
that,
just-
I think that if
Yeah, I just say it
miss,
as a Turkish.
Okay, okay.
Sorry to not
Okay.
to say English. Benim sorum silvikültür iklim değişikliği kapsamında sıcaklıklar Akdeniz bölgesinde Akdeniz havzasında arttığından dolayı silvikültürel tekniği olarak biz meşcerelere sürdürülebilir orman yönetimi kapsamında müdahale ederken hani genellikle düşük ya da orta seviyede müdahale ediyoruz. Hani gençlik çağında mesela ilk karalama çağında, sıklık çağında falan. Biz ihtiyaç duyacak mıyız acaba hani silvikültür tekniklerini değiştirmeye, daha şiddetli aralama yapmaya, hani o biyoması kaldıracağız ama yangına daha hassas, daha dirençli bir meşçeri yetiştirebilmek için daha mı şiddetli?
No. Okay, I see. I understood truly, because I think that I missed something about silvicultural techniques. Okay, if you think about climate change, the fire is not an only threat for the forest. We have other extreme events. For example, if you cut more trees and suddenly happens a storm, you know, all the trees will die, and you have to be more and more moderate, you know, and you couldn't cut much trees in the stand. The stability of the forest is very important for extreme events, but for the fires, you don't need to cut much trees. For example, for black pine issue, you have to keep less fuel accumulation. What I mean, you don't let the understory grow much. There's some way. One of the way, we have a tradition in Taurus Mountains. This community, Yörük people, are doing this very well, but we foresters force them to sell, for example, their goats, because we always look the goats that this is dangerous for our plantations, for our forests, but now we can understand that these people help to reduce fuel accumulation. This surface fire stays in the surface, underground and the litter, and doesn't go up much to branches and the crown. If you understory grows and grows much, the fire will find a way to reach a branch and then later crown. Why I'm talking about fuel accumulation and you are talking about fuel accumulation, this is the reason. Fire issue is different. You have to keep your forest understory cleaner and smaller. And we have traditions for many, many years. But we force these people to move them from the forest. Let's go to other areas. Let's do different jobs. But it helps our forest. It doesn't destroy our forest when we look at this fire window. But for the other species, for the other climate change effect, we have to be really careful when we cut and destroy our forest stability. We need to focus on less cut. Maybe we will go twice to do this job. For example, we went there, cut a lot of trees. This was okay for many years before, but now it is not okay because there are extreme events to destroy your forest. These issues are different. Okay, thank you.
I think we have to close the session panel because we are out of time. Thank you very much for your participation, and also I thank the speakers, and I also thank the Ministry of Environment, Urbanization and the Climate Change of Turkey for their invitation to organize this panel here. Thank you very much. If you want more questions, then we will be around here for a few minutes so we can discuss out of this area. Thank you very much.